So let's finish up this series of videos by talking about the linked list class provided in the Java standard library. So that remember that our interface that Java gives us is called list, and we talked about array list, which behind the scenes is implemented with an array. Java also gives us a class linked list, which behind the scenes is implemented with linked nodes. So you can take a look at the API here. Linked list talks a lot about the class, and you can read all of the details. Now, one thing to note is that behind the scenes, this class is implemented with nodes, but it's actually implemented as a doubly linked list with a head and tail pointer. What a doubly linked list means is that it's actually implemented with double nodes rather than just nodes. A double node is similar to a node, except it stores a reference to some data, only instead of only storing a next reference or pointer, it also stores a previous. So you're allowed to, each node points to the next in the chain, and it also points to the previous in the chain. In addition to that, we have a head and a tail pointer. Having this double node structure with the head and the tail pointer allows the linked list class to be more efficient at certain tasks than we could be otherwise. And again, think back about that question I asked about whether adding just a tail pointer makes for more efficient deletions at the end of a list. And think about how that would change if you actually had a double node versus just having a single node. So this is an example of what a doubly linked list would look like. So you'd have a reference to first node, and this points to some data. Each one of these double nodes still points to some data, but then also the first node will point to the next, and its previous will be null. This next node, its next will point to the third in the chain, its previous points back to the first. The next node, its next again points to the fourth, its previous points back to the second. And the last one, next is null, and previous points back to the third, and then last node refers here. So this is what a doubly linked list would look like with first node and last node references. Now, this again will allow for lots of things to be accomplished more efficiently, but as you might imagine, the code for this is incredibly more complex, right? Because now every time we're updating anything, we have to update the next reference and the previous reference, and you have to make sure that any additions and deletions that you're updating all the appropriate references. So the code obviously gets a lot more complex, but it allows us to do things in a much more efficient way. Now, according to the API page, most of the time we do want to be using array list. If you take a look at it, it's the source of this wording here comes right from the Oracle tutorial on list implementations, which you can follow with this link. The array list has constant time positional access, and as Oracle puts it, it's just plain fast. So most of the time you do want to use an array list. According to them, you'd want to consider using a linked list if you are frequently adding elements to the beginning, if you're frequently iterating the list to delete elements from the beginning. This is when you'd want to consider a linked list. However, they recommend that even in these cases, so even if this describes your task, you should still test the performance to make sure that linked list is actually more efficient than array list. So even under these conditions, it's possible that array list might be more efficient. So you want to think about linked list in these cases, but again, you do want to test it out to make sure it really is. And again, you can take a look at that tutorial to kind of take a look at how they describe that. Okay. And one more reminder about this, remember that once you kind of get out into the real world, you're not going to be using list interface and list or bag interface and linked bag. You're going to be using the classes in the Java standard library. The reason we talk about list interface and list is so that you can really get under the hood, look at that code, look at how to write the code, how to evaluate the code. But once you're out of this class, you're not going to be using list interface and list. You're going to be using list, array list, and linked list. So it's really important to know when you should be using array list, when you should be using linked list. And again, you can take a look at this link here, which talks about that. One final note here, let's summarize the efficiencies of array lists and linked lists. So it all depends on what you're doing. If you're talking about direct access, so getting an element at a certain position, definitely array list is faster. Now, we haven't talked about what O of 1 and O of n means yet, but it's enough to say that O of 1 is really good and it's much better than O of n. Okay, so array list is definitely better for direct access. We know that linked list doesn't allow direct access. You actually have to traverse the list to get to that position. Talking about adding or removing from the beginning, array list is not quite as efficient. Linked list is much more efficient. Talking about adding or removing from the middle, array list is O of n and linked list is O of n, so they're about the same. However, if you're using an iterator, the performance can actually be a little bit improved with the linked list class. And we're not going to get into that. That's a bit beyond the scope of what we'll be talking about. But if you want to look into that, you can look at how iterators work in the linked list class and see how that improves the efficiency. And then adding and removing from the end, they're both pretty fast. Again, linked list here is faster because it has that tail reference and it's doubly linked node. So this is a lot different. Note that this comparison is for array list and linked list. It's not for A list and L list, the classes that we're dealing with. That's going to be different efficiencies, but this is specifically for the classes provided in the Java standard library. Okay, so hopefully now you have a good sense of what nodes look like behind the scene, but eventually moving forward, these are the classes you're going to want to really understand. And hopefully by looking at the arrays and the node code that we've been doing, it'll help you get a sense of what's happening behind the scenes. And then you can actually use the API page of these two classes to really learn more about how they work. These are the classes you'll really be using and about when each is appropriate to use.